Hi guys, welcome to part 3 of DIY CNC by Novice. I've gone out and actually purchased all the steel for fabricating the table. I've also had been lucky enough to get a couple of orders come in from eBay. I've now got my V-groove bearings which I'll be using for linear motion. We've got a full bag delivered last week at some stage, so we're going to be using those to run on some, because these are a 120 degree V bearing. They're designed to run on round bar or round edge, and I could possibly get away with running, if I used a piece of angle, I could run it like so, but I didn't quite like the idea of having to clean up all the mill scale and so forth. So what we're going to do, or how I'm going to approach this, is I actually ordered some hex bar. Now hex bar being 120 degrees means that the bearing is going to be fully supported. So the bearing is going to sit fully supported onto the hex bar, which means that I'm going to be able to put a little bit more weight on these bearings, and I should get a smoother travel on the hex bar. So that'll be my X, Y and Z will basically, axis will be running off these bearings and the hex bar. The other thing, I've got all the actual steel. I went, instead of the drawings, I'll just reach off camera for a sec. A lot of the drawings call for like a bend to be put in, so you cut the plate out and then have it bent up. I don't have a plasma cutter. I don't have a CNC plasma cutter, so what I've thought of doing was using some angle instead to create the brackets that are required. So all it'll be is a case of drilling in the locations on the angle, and then I don't have to worry about the making the bends because I'm already using the angle. Well, that's the theory anyway. Once the machine's actually operational, then I will cut these out. I'm going to fabricate up just an in-house bending machine, and we'll manufacture these brackets. This is 5mm angle though, or 5mm. The drawing calls for 4mm or 10 gauge. It's going to be difficult to make a bender that's actually going to be strong enough to make the particular bracket. So I might look at keeping the brackets. It will depend. I haven't quite come to see. We'll see how well the machine runs before I actually make up the bracket. Really, a lot of the brackets that I've got, they've got the rounded corners. They make it look pretty. As long as it's functioning, we might look at doing it down the track. I've also doing this. One of the drawings called for. I'll just grab these. One of the drawings called for. So this is for my carriage plate. It'll run the. So this sits on the x-axis, and it actually runs so the x-axis and the z-axis sits off this carriage plate, and it's a two-part plate. It's a two-part drawing. So we have this section here. It's got the 3 slots, 1, 2, 3, and they slot in to here. Now that there is your motor mount, I believe, motor plate, and that's the actual carriage. So 4 V bearings will go on here, and this section piece will come like this. So what I've done is got a piece of angle, and that's going to be my plate. Well, so I thought, because if you actually have a look on the drawing, this section here, which is the motor mount plate, well, in the drawing you'll see that the attachment for the bearings sits higher than where the motor plate comes out. I'm thinking, right, now I'm going to have to, I don't know how I'm going to be able to do this, but I came up with a solution of tacking on a small piece of steel onto the top, and that'll give me the clearance that I need to mount the V bearings on. So the V bearings will sit on this side, out the front here, and it rolls this way on the track. So that'll give me the clearance I need. The bearings themselves were $6. I think it was at $6.50 a bearing just on eBay. 120 degree groove instead of your 90 degree. The other option I could have gone is I could have just run them on 90 degree angle or run them on round bar. Or they actually run quite smoothly on the edge of the RHS steel that I've got. So, but we'll go with the hex bar to run those on. The other thing I need to do while we're talking about the bearing is we need to create some eccentric bushes. So what we're going to do is I'll just go into my little project box over here. Okay, so we're going to make some eccentric bearings, and what we're going to do is I'm going to use a M10 bolt. Now this was me just playing around to see if I could do it. It's going to actually push through, sit on the bearing, inside the bearing, and then all I've done is just drilled a hole off centre, so that will camber. That creates so when I twist that around, and the hole itself will have a 1/4 inch bolt pushing through it, and then to space it off the back, all I'll be doing is I'll be putting a washer on the back and then a nut onto the 1/4 inch, and then the 1/4 inch will go through. The 1/4 inch goes through your hole here on the carriage plate. And that's how I'm looking to make my eccentric bearings. And then with the concentric bushes, or your standard bushes, what I'm going to do is instead of trying to drill a hole exactly in the centre of the bolt, all I'm going to do is drill out, instead of it being a 1/4 inch hole, I'm going to make it a 10mm M10 hole. So a 10mm hole, and then the whole bolt. So I get them. The whole bolt will push through the carriage, and there'll be a spacer in here, and then that'll just screw on like so. So that's the idea for the mounting of the V bearings onto the plates. So what I'm also going to do is I'm looking at getting some 250 GSM card to print these out on. Then I'm going to trim around them and use those as templates to mark out all the contours and so forth. So when I'm using the plasma cutter to cut the angles out, so while I'm using the plasma to cut, wrong piece of steel. So I'll lay it on the steel like so, and then I can scribe around it to get the profile and the dimensions, and then cut it out. Because these really aren't critical, because I can play around with them, and if I have to make any sort of adjustments, I can get those adjustments out of the eccentric bushes for the hole. So hopefully I'll try and keep it to a couple of mil tolerance, or a mil tolerance if I can. We'll see how we go. It's going to be a fun project anyway. So the steel we've got is, I'll just swing the camera around so you can have a look. So there's pretty much most of the steel we have. 50 by 50. 50 by 50 by 1.6 RHS. We have this is going to be used for the carriage plate. This here, this piece of 5mm by 100 is going to be used for some of the motor mounts. Then we've got the rest of this here, these pieces, these 4 pieces are going to be used for the table themselves. These 3 pieces, again, the top sections of the table. I've got some 40 by 40 by 1.6 at the back. That's going to be the arm that overhangs over the table to hold the torch cable. And then I've got these rails for the Y axis. Now, the bearings as themselves, they do roll on here, but this piece will literally be just tack welded like so, and then they'll roll like so. So these will be, this hex bar will be tacked on. Then the mounting of the rails on the side that sits on top of the table, I'm actually going to slot these, or I may actually instead, if I'm going to use a 8mm bolt, I might drill a 10mm hole. Gives me that little bit of clearance so that when I'm aligning the axis or the Y, because it's going to span across and I've got rollers on both sides, just so I can get that that spacing correct. What I'll do is I'll run the gantry all the way to the homing location, tighten the bolts, run it down to the furthest point that I can machine on the table, tighten the bolts down there, and then that should mean that my rails will be parallel. I'll be with the x-axis slightly different. What I'll be doing there is I've actually got at the back here is a piece of 65 by 5mm flat bar that will be attached on like so. Then the hex bar again will just be tacked on, probably on this side. I'm not sure if you can see that, but basically the hex bar will be tacked on to that 5mm that'll be sitting across the axis with the hex bar hanging out the top. So that's the plan. We've got some. I've also got some 2mm plate steel down here that will be used for things like the torch holder. I've also used it for the Z carriage or the Z axis. It's a couple of parts, but and there's some bends involved in that, so I might have to look at making just a really cheap and nasty bending machine out of a couple of bits of, whether it's a couple of bits of angle that go like this with a hinge on it to bend it like that with a clamp on the top of it. I'm not sure. We'll come to that once we get the table done. But I have sort of been a little bit slack with this latest video, only because I had to actually build the bench that this is sitting on, because this shed that I'm in, as I'm not sure if I've mentioned, but we built a brand new house. We've been here about 6 months, about 9 months, sorry, and the shed has pretty much just been for storage at the moment. It's still got stuff pretty much everywhere that I need to start to get organised, but with 3 kids under 2, it's time can be a bit precious, so I had to build up the benches to put all my gear on, and so I've got some sort of workbenches that I can work off then for this fabricating process, and then the table will sit in the middle of the shed. The shed's 6 metres by 6 metres, so the idea of having the table positioned right in the middle of the shed will mean that I can walk around it and go from there. So that's about it with the steel side of things. What we've got here, we'll look at getting the plasma cutter out shortly, get the compressor fired up, and we might do a bit of testing. All the testing will be used in the cutting of certain brackets and so forth. For example, this is going to be a good test. This is my 5mm angle, and it needs to be cut in half, so we'll look at marking it up, and we'll see how well the plasma cutter goes cutting this in half, getting it ready for the Y gantry angles. And then I've also got to look at cutting. This is some 5mm plate as well, so we'll look at using the plasma cutter to do some cutting, and we'll see what sort of accuracy we can get from the cutter, how wide our cut line's going to be, or the kerf, and we'll see how much dross is left on the back of this steel, and how well and how easy it cuts. So let's get to it. Okay, so we finally get to test the plasma cutter today. Well, I finally got around to doing it. The footage isn't that great. We had some issues down in the shed. At the moment I don't have power in the shed, so I have to run a heavy duty extension lead out down to the shed and plug it in, and of course I decided to go out and record it today, and my camera battery's flat, so I had the power pack plugged into the camera so I could record. And what was happening is that my poor little surge protector board was triggering all the time. Every time I was cutting with the plasma cutter and the compressor would kick in, it'd just short out the board and the video would cut out. So I've got I'm looking to do some more testing later on to show everyone what this little unit can do. From what I played around with it a lot more off camera than on camera. They reckon the unit will cut up to 1/2-inch steel. Yeah, I don't think so. We were having some issues when we got to about 5-6mm steel. I had it cranked out at 50 amps. The pressure was set as per the 60 psi or 58 psi in the manual, and it didn't quite cut as nicely as I thought. 3mm steel, as you'll see in the video, is excellent. 5mm steel, or the 5mm angle I was cutting with a straight edge, that was quite impressive. But when you go freehand on the 5 and 6mm, it could be just my technique, especially with the 6mm, it just wouldn't. I had a lot of issues cutting it, and in the track you'll see some of the brackets that are being cut for this, and it's they're not pretty, folks. They're not pretty at all. So looks like this particular machine, once I get it up and running, I probably wouldn't push it more than 3mm using 3mm plate steel, for the simple reason it just doesn't have the grunt, I believe anyway. Okay, so this is me cutting through 3mm steel. You'll notice on this very first cut that the torch moves. That was mainly because I hadn't tightened up the head properly. See, there we go. So I think I had a bit of a headless moment, but I was actually really surprised on how easy it does cut through the 3mm. Now I had the settings, I think I had it on about 40 amps, 60 psi. You'll notice there's a little bit of dross left over on the cut, but overall it's not actually a bad machine to use on the 3mm. I had some dramas with keeping the airflow up, only because the little regulator that sits on the back of the unit, I need to get some proper sealing tape to seal up the connections, because there was a pretty substantial air leak that I was playing around with. So this being on a power supply or a surge protector, it would cut out, and as I explained earlier, the fact that it was on the camera was actually on the power pack, it turned it off. What I didn't realise is when the camera got reset or turned off, it it went back to its original lens setting, so there's no zoom on this one, but you can sort of get an idea. If you use a straight edge, I was using some 5mm plate 5mm flat bar as a straight edge. Really simple to start, and as a guide you get some really nice clean cuts. I'm just drag cutting here, so literally just dragging the tip of the torch directly across the steel. I tried to show you this again. I had all sorts of dramas out here. I was trying to show you here the dross that was left over, not realising that the camera had reset. So it was pretty simple. I've got a couple of sawhorses there that I've used to sort of make a temporary table at the moment. I actually use that as a table saw. I've actually got my circular saw mounted directly underneath where the steels are running across the table. So I just thought, for the moment, give you the best bit of light so you can actually see what I'm doing. And the machine handles 3mm steel really, really easily. I was actually quite surprised when I first started using it on the 3mm. It was just, I couldn't believe how easy it was to cut. A lot of the time I've used a cold saw or I've used an angle grinder, and the fact that you can just run the torch directly across and cut is amazing. This we've moved on to the 5mm angle, and again the power ball was tripped, so that cut was actually really good. This time I try again and it cuts again. I get pretty much most of the way through and it cuts out again. And because it cut out, when I tried to restart it, I noticed a lot of the dross itself or the bevel would pull in the cut, and it would actually bind the steel up again. So hence why I had to run it across a couple of times there. Well, as you saw in the video, we had some fun and games out in the shed. So overall, the machines, it's not bad for the money I paid for it. It's going to struggle on anything above 6mm, but you get what you pay for, as I said. Moving along, we'll start to fabricate the table, get a work area. I need to clear some space in the shed so I can actually create the table. But I have created a little prototype box for all the electronics, made out of some 12mm ply. So that'll probably come in a later video. I'll run you through the actual box. And on the electronics side of things, I'm just waiting for a little relay to come in the mail. Again, purchased off eBay, just so I can use that to trigger the torch switch. And I had, this is one for that video, but we had some fun trying to figure out how the torch switch actually works with the little CNC shield. So we have to go in and make a few edits, but I'll leave that to that video to go through. So again, thanks for watching. I really appreciate the comments that I've received over the last couple of videos. Again, please comment if I can ask any questions. I'm more than happy to do so. And subscribe along, because it should be a good journey. Thanks for watching. Cheers.